Let us talk about cylindrical coordinate system in this video. We talked about spherical coordinate system in the last video, and we saw that we can represent any point with the help of r, theta and phi in the spherical coordinate system. Yes, and now in the cylindrical coordinate system we can represent any point. Let's say this is our point P. We can represent this point with rho, phi and g. Okay, so we can represent any point with rho, phi and g. Now this distance rho is the distance of this point P from the z-axis. As you can see in this picture, if you draw the perpendicular from this point onto the z-axis, then you will be getting the length of this distance rho. Now what is the angle phi? Angle phi is still the same as we were having in the case of spherical coordinate system. This is the angle from positive x-axis. So now if you kind of take a projection of this point rho phi g into the xy plane, you will be having this point as rho comma phi, and this distance would be same as this rho. Yes, because it is the perpendicular distance and this is the projection we have taken, so this distance would be still be the same as rho. Yes, so this is point rho comma phi. Now from this point, if you move a distance g into the direction of this g cap, okay, which is shown here. So if you move a distance g, then you will be getting this point rho phi g. So now let's try to get the relation between the Cartesian coordinate system and this cylindrical coordinate system. So let's imagine this is the Cartesian coordinate system. Then this point would have been x, y, g. Now we want to find the relation between this x, y, g and the rho, phi and g. So I would be drawing the Cartesian coordinate system with this green color. Okay, so this point would be x, y in the Cartesian coordinate system, and in the cylindrical coordinate system this point would be rho, phi. Okay, so I am making both of these coordinate system in the same diagram. Now in the Cartesian coordinate system, this distance would be our distance x. Yes, and this distance would be our y. And in the cylindrical coordinate system, the rho would be this distance. Yes, and this would be angle phi. So let me draw this triangle here. This is our distance x, this is our distance y, and this is our distance rho in the cylindrical coordinate system, and this is our angle phi. We can easily find the relation from here, that this x would be rho cos phi. Yes, and the distance y would be rho sin phi. You can take the reverse relation also. If you this is the 90-degree angle, and if you use the Pythagoras theorem, then rho would be under root x square plus y square. And if you want to get the phi from in terms of the x and y, you can say the tan of phi would be pi divided by x, so phi would be tan inverse y divided by x. Yes, so in this way you can find the relations vice versa. Now what is the z? In Cartesian coordinate system, this distance would have been the z, and in the cylindrical coordinate system also, from this point if you go to this point, this distance z would be the same. So we can write easily z is equal to z, because it is the same in both of the coordinate system. Yes, so this is the relation we found. This is very easy, you just have to little bit of do the trigonometry. Now once we have found these x, y and g, let's try to get the length of differential elements as we saw in the case of spherical coordinate system. Now let's try to calculate these length of differential elements. So what is the length of differential elements? What do I mean by differential elements first of all? Okay, so let me remove this so that I can write over here. So first let's see what is the differential element. In the Cartesian coordinate system, if you want to go from a point x by g to a infinitesimal small distance, if you go in the each direction, then you will be landing up with a point x plus dx, y plus dy, and z plus dz. Yes, so let's say this is point P and you are moving this point P to P dash. The displacement vector was given y, dl vector was given y, dx I cap plus dy j cap plus dz k cap. Yes, because you are moving dx length in the direction of x, dy length in the direction of y, and dz in the direction of z. So this was the simple. We saw in the earlier videos, in the case of spherical coordinate system, let's say we are initially at point r, theta and phi, and we are moving from this point to a small distance, and the coordinates of that point are given by, let's say, r plus dr, okay, theta plus d theta, and phi plus d phi. So we saw that the length of this element in the direction of r was given by dr. In the direction of theta, we calculated it as r d theta, and in the direction of phi, we calculated it as r sin theta d phi. So the differential vector or the displacement vector was given by, dl vector was given by dr r cap plus r d theta theta cap plus rho sin theta d phi phi cap. Yes, so it was the displacement vector in the case of spherical coordinate system. Now similarly, let me go below so that I can write. Yes, so now similarly, let's say in the case of cylindrical coordinate system, we are initially at point rho, phi and g, and we are trying to move very small distance from this point, okay, and let's say we are going very infinitesimal small distance and the angle in each direction. So let's say we are getting to the point rho plus d rho, phi plus d phi, and z plus dz. Okay, so from this point, let's say this is point q and we are going to a point q dash, then what will be the length of each element? Okay, so let's first try to get the length of element in each direction. Okay, so if you are at point rho phi g initially, yes, let's say you are at this point, this is our point q, and from this point in the direction of rho cap you are moving, yes, in the direction of rho cap you are moving, and distance you are moving is simply d rho. Okay, so this is the distance. We can easily say the length of the element or the length of this vector which you have moved would be given by d rho, because this is the length. Okay, so from rho to rho plus d rho, the length of the element would be given by d rho. Yes, now in the direction of phi, you are moving an angle from phi to, let's say you are initially at this angle phi, and you are moving a very small angle. Okay, so you are moving this angle, and this angle is given by d phi. Okay, so you are initially at this point, let's say Q, and this is the, let's say, okay, don't confuse with this Q. Okay, this is different point I'm taking. So this is, let's say, point Q, and this is, let's say, point M. Okay, so let me draw this circle here. So this base of this cylinder would be the circular portion. Okay, this would be the circle. So this is our Y, okay, and this is our X, and this is our circle. So initially you are at this point at angle phi, and you are moving at this point an angle d phi. So the length of this arc would be given by this radius times this angle which you have moved. So rho times d phi. Yes, the length of the arc is given by radius times the angle which you have moved. So from phi, if you are moving phi plus d phi little bit, the length of the element, which would be this, given by rho times d phi. Yes, it would be rho times d phi. Now in the direction of z, if you are moving from this point rho phi g to a little bit z plus dz, okay, then the length of this element would be given by dz. Yes, this is the length, so you can simply difference z plus dz minus z. So length of this element would be dz. So now I can write the displacement vector in the general form would be given as dl vector would be given as d rho in the direction of rho cap plus rho d phi in the direction of phi cap plus dz in the direction of z cap. Yes, and once you find these lengths of element in each direction, then you can easily find the surface of the surface element, infinitesimal small surface element, and the infinitesimal small volume element. You can find the volume of that. So let's try to first calculate the volume of the volume element. Okay, so let me first remove these. Okay, now what do I mean by infinitesimal small volume element? So if you take any small volume in this cylindrical coordinate, so let's say the small volume element is given by this. Okay, so this is the volume element. I am just making randomly. Just forgive me for this bad quality of drawing. Okay, so this kind of would be the volume element. Okay, so now once we have calculated this length is our rho into d phi, yes, in the direction of phi cap, this we have found as dz, yes, and this horizontal or this in the direction of phi we have found it as d rho. Then you can multiply length, height and width in order to get the volume. Okay, so these lengths are very small, so you can consider this as a rectangular prism. So the volume dV would be given by the length of these three elements, which are rho d phi multiplied with d rho multiplied with the dz. Yes, so this would be the volume of the volume element. Similarly, you can find the surface. Now surface depends on in which plane you are. Okay, so if you are in this above plane, the surface area would be different, and if you are in this plane, the direction of the area would be this, and if you are in this plane, the direction of area would be in the positive z-axis, and if you are on this curvature area, then direction of z would be this rho cap. Okay, this area. So you can find, you just have to multiply it with this length and this. So in this surface the area would be rho d phi multiplied with dz. Yes, so this is kind of rho d phi and this is dz. Yes, so if you are in this above surface, so this would be different. Okay, so you can find it easily. You just have to multiply it with length and height. Okay, so this is about the cylindrical coordinate system.